Hello, my name is Kyle, and today I'll be presenting the partial pitch of my graduation thesis, an analysis of game performance at different abstraction levels. Let's get started. First, the structure of this presentation. I'll be starting with an overview of what is this project, why is this project important, how will it be done, followed by a progress report of what has been done and what needs to be done in this project. Finally, I will be providing an achievable plan to this project's conclusion. So, let's start with the overview. What is this project? This project is an analysis of game performance at different abstraction levels. Of course, that might sound a bit confusing, so I broke it apart in a few different levels. A practical study with quantitative and qualitative data of game performance and development ease of use using different levels of abstractions provided by game engines. So, why is this project important? Game development is a growing market with many game engines, as you can see in the following image. These game engines vary a lot in their abstraction level, which affects their ease of use and performance. As you can see in the image, a higher abstraction level means higher convenience, but that also means a loss of performance and control. That can be seen in the image with three examples, Raylib, Bevy, and Godot, that go from low, medium, and high abstraction and convenience, and performance and control. There are very few studies on the effect of abstraction in the game development process and resulting gains. Herein lies the objective of this project. I would like to provide benchmarks in different abstraction levels and an analysis of the advantages and disadvantages of each level using these benchmarks. So, how will it be done? I will be using three open-source game development tools that have been chosen to represent three different levels in abstraction: low, medium, and high. Raylib represents low abstraction and uses native C and C++ structures. Bevy has medium abstraction and uses entity component systems. And finally, Godot has a very high abstraction level and uses its own node structure. This project has a few game prototypes that will be implemented in those three tools using their own structures and techniques following a template that represents that abstraction level. These abstraction levels will be then compared. Finally, the results of this development process will be documented and presented at the final thesis together with the performance of each of these game prototypes in the different abstraction levels. All of the assets used throughout this project are from Kenny's Game Assets. Here are a few examples of the assets that will be used. So, what has been done so far? I have set up the engines, which here you can see a conclusive report of the engines and how easy the setup process was, and also how to do it yourself. I have done three templates, one for each game engine, and each template representing the game engine's core way of operating. I also have the frames per second, which can be gathered from all three game engines straight from the game window. And finally, there is a first game prototype which has been developed. This first game prototype is called Basic Rendering and represents a little player character that can move left and right with animation and rendering to see how much that can affect performance in these different game engines. Here you can see the example of Raylib, here you can see the example of Bevy, and finally here you can see the example of Godot. So now, what else has to be done for this project's conclusion? First up, more game prototypes have to be implemented. I am planning on having a total of 5 prototypes including the template. In-depth analysis. I would need to do a more descriptive analysis than just the little video that I've shown you now with the FPS showing in the window. I would like to properly say how easy or hard it was to use each of these tools and what performance they achieved. I would like to have a final pitch similar to this one, but overviewing the findings of the full project, and also I will be making a conclusive report that will be written and made available to the public with a guide on how to study and understand the repository with the games and the prototypes. So now, let's see my achievable plan to the project's conclusion. This plan considers the upcoming week as a 7th week. Weeks 7 through 9 I'll be making one game prototype a week, which means that I will be having 3 new game prototypes. Together with the last 2, I will have a total of 5. Then in week 10, I will be measuring the results and organizing the public repository so that it can be easily available and understandable to the public. Finally, in week 11, I'll be filming the final pitch video, and in week 12, I'll be making the final conclusive report. Other resources, such as the project's proposition, the GitHub page, and contact information, can be found in the video description. Please do have a look if this project interests you. Right now, on screen, you can see the thesis proposition. And now on screen, you can see the project's repository and the basic rendering and template examples. Thank you very much for watching, and I hope to see you in the next video.